DTrace to Linux, and definitely appreciate people's flexibility that we can schedule a little bit around to make it possible to come here and basically talk a little bit about what we've been doing with this. Obviously, it's nothing really new. I mean, it's truly a port. We've been working from the code that was in Open Solaris, so there's nothing really much new to it. It's extremely well-written code, which makes our life a whole lot easier, for certain. So we could mostly focus on the things in the areas where Linux is, fundamentally different from Solaris, and that is where, obviously most of the time has been spent. Notably, I would have to say the interesting parts that happen is, things like memory management, which is significantly different, which was a little bit surprising to us initially. So we have to spend quite some time on that. I would say probably the most influential change that we had to make on our end, which took a fair amount of time, is doing things like, for instance, a syscall provider. Obviously, handling syscalls is quite a bit of a headache. There are, as we found out, obviously, a couple of them that are special cases where you have to write a bunch of assembly code to basically make them work, which turned out to be not as much of a headache as I would have expected. And again, I would give credit to the original DTrace code for this. That actually made my life a whole lot easier with that. One of the fundamental changes we had to make on the Linux side for this, which most likely will still get somewhat of a, I would say, criticism from the Linux side, is that the system call table was made read-only in the kernel quite a long time ago, mainly for security reasons. Obviously, that doesn't really work well. We toyed for a little bit about ideas to keep that and work around it, and basically in the end decided that that's just not the right way to do it. Again, the way it was originally designed in DTrace is elegant. There's no reason to basically not use an elegant approach and break through this read-only boundary just for the purpose of the fact that somebody decided it should be read-only. So for a kernel that has DTrace in it, the system call table is no longer read-only. Ultimately, we've looked at this for a long time. I really don't see where that's a security risk compared to any other tricks you can use right now to basically even deal with read-only system call tables. So people have to they are going to have to get over it. That's how you want DTrace, just deal with it. So that worked, and that was not a problem at all. We also had some interesting times with getting the static probe mechanism to work, and that was, I would say, mainly my fault for basically using the wrong tests to make sure it worked. Because one of the things that we did not anticipate, and which, interestingly, again, I would have to put some blame, I won't say blame, I'd have to say some maybe oversight on the side of Linux kernel developers, that page faults apparently did not have a notifier mechanism in the kernel. It was very nice that we could, for instance, trap general protection faults and attach a notifier to that, redirect these things to the DTrace core and handle them correctly. For page faults, it was not possible. At some point that was possible, somebody took it out of the kernel. We've put it back in, because otherwise, again, memory accesses in a safe way are not possible otherwise. So I would say, again, some positive contributions, I think, to the Linux kernel are coming out of this work. Overall, I would say it's been an interesting process to do this, because of the fact that I would say overall the structure of the kernel build process, all that obviously does not match Solaris. Solaris, the concept where essentially the kernel in itself is essentially an object. Kernel modules are objects. That actually is pretty clean. On the Linux side, I wouldn't say it's less clean, but you definitely have to deal with a kernel image that is, for all intents and purposes, a standalone linked entity that is executable, and modules are, modules that are linked at runtime. So we took somewhat of a deviating step from, I would say, the original designs as far as we could uncover them with DTrace, and obviously had to decide on this can never work the Solaris way. I was not going to write a runtime linker loader for the kernel when this thing is already basically linked. So we basically diverted all that to the original build time. Since, well, we have this image, you might as well do it at compile time in our case. And so the list of static probes is basically compiled out of the build process of the kernel, and basically is linked into the kernel. And then, we do obviously post-processing later on, because we don't want to, bog down the kernel with information that might not get used. But ultimately, we, made a bit of a change there. On the module side, obviously, this has to work differently. So I'd say in all, probably the majority of the code of DTrace was able to be ported without too much headaches. There's, like I said, the typical differences because of the fact you're dealing with a different operating system. But once you kind of have identified the typical places where these things change and there's different behaviors between how things are implemented, it goes fairly quickly. And the way we basically worked on doing this port was, instead of basically taking just the whole code base and go file by file and just port the code, was to take a slightly longer approach and to essentially go with, we start from essentially the entry point of DTrace as a module, go through different operations that can be executed on that, and essentially port things on a function by function basis going through execution paths. So essentially any dead code that might have still been in there from Solaris days essentially never got ported, because we never needed it anywhere, so it's never going to get ported. And so there are still things that right now are not ported for basically functionality that has not been touched. The only exception that was made, obviously, is for implementation of operations. We basically just went through the whole list and said everything has to be implemented. Just going by, okay, whatever the scripts we have are going to need is just never going to cut it. So, but using this process, we essentially kind of had an almost built-in, almost unit test system of doing the port, where we knew that functions would only be pulled in when we needed them, and they, through necessity, had to work, because the side effects were basically much easier to cut. And given the fact that DTrace itself has a fairly decent test suite that comes with it, I would say definitely made life a lot easier. So it's, overall it has not been, I would say, really doing anything new in many ways. I mean, it's new because it's on Linux, but it's not, a very large amount of code that has been written. It's just been a matter of doing it in a very, very careful way. And I probably can't count how many times I've crashed the kernel, and still do, and actually get pretty proud of it when I do, because now I can actually find out why. And the very interesting part I found with doing this with DTrace is that most of the time, DTrace is part of the process of finding out why I crashed it. So in that sense, again, DTrace actually is obviously very useful. I mean, otherwise we wouldn't be here. But it actually helps in pretty much the development process of doing the port on Linux, because the parts of it that work, which is already fairly substantial, is definitely helping with finding issues with the new code that we're working on. I guess I'm going to keep it that brief because I assume there are questions.
Mm-hmm. Yeah, so I've always got a lot of questions.
Sure.
So thank you so much, and it's terrific to have you here, and thank you for the candor and explaining. Just a couple of random questions. One, did you keep the same mechanisms? I mean, the mechanisms that we used for STT, for example, were almost historical the moment they were written, and for kind of very weird reasons, we used an illegal opcode vector instead of the breakpoint vector. Really should have used the breakpoint vector. That was again, long story there. Did you, I mean, unfortunately there's nothing in the code that says we really shouldn't do it this way, so you may have gone the illegal opcode route, or did you?
I actually went the illegal opcode route.
It does work.
It does work, and right now, at least on Linux, nobody else is using it.
That's why
convenient.
That's actually why, the reason why I did it is because no one else, because it's not. Int3 is very crowded, and UD is not at all. And
that is one of the reasons why we went with that. One of the decisions made very early on was to basically try to stick as close as possible to what was done, except in those cases where we, from at least our point of view, believe that maybe some decisions that were made earlier on were wrong, in our opinion. or where we just felt that it really needed to be done differently. But I really saw no reason not to use it. And since there is already quite some other projects that try to work towards tracing that are indeed using the breakpoint vector, and there isn't really a very nice, clean system where we can say, okay, we'll just hook on and have like a notifier list, and 25 traces get called whenever there's a breakpoint. The infrastructure was not there, and we were trying to also minimize at this point the changes made to the core kernel, to be able to support this.
I definitely am using that. The reasons I used the legal optrend instead of in3 were because of organizational reasons, exactly the ones you outlined. I think it's funny that they hold true in a completely different source base. The same problems. So, just another quick question. Do you have the same constraints on safety? I would assume that in terms of, is your design center that DTrace is as safe as it is on the other platforms that it's been?
It's obviously the goal.
Sure, of course.
I'm definitely not going to say it is now.
Of course.
But yeah,
you're treating it as the goal.
The idea is definitely that having DTrace enabled should essentially not jeopardize the safety and stability of your system.
Great, terrific, thank you. And then also PID provider. Do you intend to do the PID provider? Is that something that is, to the best of my knowledge, it's only you guys at Apple, and then to the degree that FreeBSD has begun to wade into it, but the PID provider is a really tough road to hoe for our
It's difficult, but it's definitely something that's in the plans that needs to be done. It's, from my personal perspective, it's kind of, if we don't, then we're kind of missing out on probably 70% of the usefulness of DTrace.
Yeah.
So it has to get done.
Okay.
And it's just a matter of doing it in a safe way and working out what is the best mechanism to do it. And also, then we are treading more in an area where other people have been treading, and it's a matter of, how far can we cooperate? Can we reuse things? That needs to be figured out.
Steve, I'd be interested in your opinion on this. I think that's probably the steepest part of the path. It's got to be the PID provider.
Yeah.
But it's great to hear that your aspiration, and you've got reason to believe that it's attainable.
It is attainable, and like I said, the main focus really now has been to essentially stay away from it a little bit. And I have coworkers who occasionally bring it up from, but we really should start thinking about it. No, I don't want to. Not because it's difficult, but mainly because, at least in my viewpoint of how we've been structuring the port, the DTrace core itself, the core functionality has to be as rock solid as we can get it before we start building up about it more, and that's really been the focus.
To Brian's question about where we're PID provider, I've seen there's the syscall provider and some of the STT providers. Do you also have like FPT, or what order are you tackling the providers in?
I can't give you a strict order right now because it kind of tends to change a little bit, also depending on obviously need from people who actually want to be using it already on an experimental basis. But FBT is already pretty far along. The only reason it's currently not in the current code base is that it definitely has some issues that I still keep running into quite often, and so it needs to mature a little bit and get some of those issues worked out. But that definitely will be something that is targeted for our next release to get in there. Turns out to be actually not that complicated either. But so it's somewhat of a variable, I guess, list of order in which providers are being tackled, and we keep re-evaluating it, on I would say almost sometimes a weekly basis to see, and it's not just let's do the low-hanging fruit first, because that's not really helping out. It's really based on what is needed at a certain point, and also trying to organize towards what is going to help us if we get one done, that basically the other ones can build upon it.
I don't work on Linux, but I tell you, as a kernel developer, solving problems, both bugs and performance issues, the FBT provider, it's almost the exclusive. The FBT provider has made my life so much better that I almost don't even need anything else.
Yeah,
it's rare that I have to go to STT.
That's why it works for me. It doesn't work apparently in too many other circumstances, and it's just in my development tree. But yeah, the main reason why, for instance, SDT was done because it was just a core structure that need to be done to essentially exercise a very important part of the DTrace core. But as you can see in the code that is currently out there, the amount of static trace points in the Linux kernel right now that we put in there is very minimal. It was enough to basically at that point say, fine, we know that most of the code works, and we're adding them as needed. But FBT right now is my main target to get out there.
So can we reasonably expect to see this in Linux distributions at some point in the future, or just a specific one?
That's something I can't answer. I'm not sure where policy-wise, obviously, we're not doing this work to basically be sitting somewhere in the back corner. But I don't know where things will grow in the future. Ultimately, the code is out there, obviously. In the Git repositories, we have basically both the GPL kernel code and the CDDL code out there. And definitely the hope is to basically make this a living project that can work towards contributions. And I would definitely hope that basically I can go towards wider adoption, but it's something I can't really speak to at this point in terms of policy or plans.
This is, I think, an interesting question. From the perspective of the Illumos community, right? We've always said that the CDDL is what we prefer, but it's not as helpful with Linux. And I'm wondering if, in this particular case, it makes sense to evaluate whether we can, as we take in contributions, particularly around this subsystem, to facilitate collaboration, do some kind of dual licensing thing.
I'm going to make this a licensing-free zone, actually. So
Nice.
just because the first question I've ever gotten in every DTrace presentation I've ever given is a licensing question. I actually don't want to have a licensing discussion. Let's do that over beers.
And it's something I can
I don't
really
have
speak
a
to
conversation
personally.
now, but it just.
It's a good point, I guess, and maybe this is the question you're going to ask. One of the things that we've seen that's been critical on other ports is what pulls the port, and this is true of DTrace, this is true of the original implementation of DTrace. What pulled the effort was the fact that, just as you're describing, using DTrace to understand the problems, it was kernel developers beginning to use it themselves. And I know it was a real acceleration for you, Steve, is having folks inside of Apple that were using it to solve problems. And boy, did things just begin to start moving once you're actually using it to solve real problems. Do you feel that you're on a trajectory to get that kind of traction inside the Linux community?
We're definitely working towards that. It's like with anything, it's new, right. And with the Linux world, I think things are a little bit different in the sense that there's many more players, and there are sometimes more strong opinions about what's the right way to do something, which is good. I mean, it's a matter of having some diversity in there. But one of the things that we definitely were from our side working on is to try to essentially get people to better understand that DTrace is not this thing that exists on Solaris and we don't like Solaris, but more on it's really a useful thing. And like for instance, point out, macOS has it. So but sometimes work, because if you say macOS has it, then there's at least half of them that say, well, why doesn't Linux? So, but it's kind of working on that almost public relations style approach of trying to convince, indeed, kernel developers largely to say, well, look at it, give it a chance and see what you can do with it. It's one of the things that I know that Wim Cookhart's one of the examples he put on his blog of a DTrace script, which to some extent can be considered totally useless, which is kind of almost a PS3 style output, but it kind of gets people's attention, especially on the kernel side. It's kind of, okay, so how did you do this? And it's something that's totally, to some extent, external. And so it's really trying to explain to people and trying to show them through example, why you can really do this. And like some of the examples that that have been shown here. Also, when I was not here, I was kind of listening to one talk and looking at the online stream at the same time to try to capture it. There are good examples of showing things that otherwise, that for instance, systems don't allow you to see on the internals. Some latency issues that you can't otherwise capture very well. And using those as kind of eye-openers from, look, DTrace can do this and it can do a whole lot more. Can we help you? And trying to, offer help there towards people that can really benefit from it. And if they capture it, then indeed that will be a big drive. Of course, that also means that they'll probably overwhelm us with questions for, doing much more than we can do in limited amount of time sometimes. But that's definitely the way we want to go.
it's definitely important to sort of get it out there. The one thing that you'll see across a lot of the how we solve those problems with DTrace is they were running somewhere that already had DTrace. So you've got a problem that only occurs every, after a month of a specific type of load or every certain number of days or something. You can't bring it back to a lab and reproduce it. But what I have often happen is that happens at a customer site on Linux, and I have no visibility tools.
Yeah, and one of the things that helps here a little bit is that before I started actually on the DTrace part, I wrote just internally as basically kind of tracing utility that basically was just capturing snapshots for statistical analysis and doing it in a way where basically we would be able to capture data. Even if the whole system came to a crash, we would be able to get it out of the VM core and do post-analysis. And people have looked at that. People thought, especially from on the support side, hey, this is really cool. This is a tiny thing we can use, and it's it's safe to use, and it's kind of nice to be able to say, well, yeah, I'm not really developing that anymore, but we have DTrace now, and soon we'll be able to do this and do this and do this, and it's kind of like, you had this one little utility that could do maybe 2% of what DTrace can offer, and it's that kind of ultimately, I don't like to do marketing, but it's a little bit of marketing to get the job done. Yeah.
So with a lot of other Linux tools like OProfile and SystemTab, you have a huge hurdle in getting type information there, and like some distros actually don't ship any kernel type information, or finding that package ends up being an hour-long process and then it still doesn't work. So how are you guys working to address that so you guys actually get type information? Are you bringing CTF along with you? Or
CTF is going to have to come along. That is currently in the process, and it's it's a nice thing. It's a bit of a headache, which I'm sure I'm not the first person to mention that. But yeah, no, CTF is going to come along at this point. It's again one of those, it is there, it has its flaws, but why on earth would we not use it? And it has been somebody's fortune of mine, but it has been somebody's headache to get that type of information, especially like for instance for kernel modules, things like that. But yeah, that definitely is the way to go at this point. If somebody comes up with something better, or even at some point we decide we're just getting disgusted with some of this because it doesn't work in other cases, then it's something that we would try to bring up to the table. And we have an alternative proposal on it. But yeah, right now I would say CTF definitely is on its way.
You mentioned modules. Do you support modules, tracing modules?
Right now, no. We will. It's definitely in the works. It's again one of those trade-offs we made where basically going with the main kernel, making sure that we could do tracing on there as the very first targets. Well, right now it's no more the very first, but as the main targets to be able to make sure that we can really have as robust as possible implementation for the DTrace core. And again, modules is like, at this point, pretty much the next step. With the FBT provider, modules is essentially being considered as, I'm working on that at the same time. For static probes, that was basically pushed aside for a little bit, just to get a few other things going on.
So I think in every port there's an element of fork, right? There's I think we have kind of a tacit agreement that we'd like there to be one DTrace. If you write a script on one platform, it should run elsewhere. If we don't achieve that, then there's kind of what's the point of writing these scripts? What's the point of these static probes? To what degree do you see the work in OEL as something that's going to march along with the rest of DTrace versus something that might go off in its own direction?
I guess I would characterize it, at least from my personal perspective, more of a march along with as a just let's all march together. So I think there is a certain level of cooperation obviously involved there. There is always, like I said, there is an element of fork in the sense that I wish we could do indeed a code base where you can just have like some conditionals in there that basically say, okay, this is now Linux, and I maybe have thought about it for about 30 seconds when I was embarking on, from my side at least, on this, and it's like it's just ridiculous to try to do it.
And this is something we talked about 4 years ago in the context of FreeBSD and the Mac port, and it's great to talk with some of you guys too. But that what's there in what's effectively the main DTrace repository is not the best form possible to make it available for other people reporting, and we should probably figure out ways to make it so that we can integrate those upstream changes, or those changes upstream, so that people aren't constantly in merge hell.
Well, I think the question I would have is because, I mean, for what it's worth, the good news is that those bits, the big bits, haven't been moving. Now, dynamic translators will change a lot of that. I mean, one thing I would hate to do is go refactor a bunch of code and then give Steve a diff where he's just like, oh my God, no, not code restructuring. So we want to figure out a way. We want to figure out the ways that we can do kind of the minimal amount of disruption to existing platforms while still making your life easier.
Yeah. Well, the main thing we did was basically take a very, very large dtrace.c file and cut it up into lots and lots of small pieces. But that's ultimately immaterial. But one of the goals we definitely have, where possible, is definitely to essentially maintain. I wouldn't call it true compatibility because it's almost impossible to do. But to the extent possible, to make things if somebody has a Descript, then with minimal changes, it should be able to basically be adopted on Linux if it exists on a different platform. Same way that where there's APIs, for instance, if you want to write a custom consumer, you shouldn't have to basically start from scratch. And I can't guarantee that's always going to be the case that we can maintain that, but obviously that is definitely a goal that we have to do it to the extent possible.
Because I say one thing is if there are places where we can make it easier, again, feed them upstream, let the DTrace community know how we can make it easier. I'd also have there's a cautionary tale in FreeBSD who went down the path of taking dtrace.c, carving it up into 50 pieces, and then at some point there's a merge that John Burrell made saying that was a big mistake. So just a heads up.
Yeah, I would say I have not reached that point yet, and it might just be a different approach of doing it. But right now this seems to be actually working out very well, and it just.
The concern is going to be, and I know it's an idiosyncratic decision, to put it mildly, to have such a large .c file in the kernel. And it's much better factor in terms of files and user land. So I apologize for that. The challenge, the thing I'd be concerned about is that I do see more changes to core DTrace coming in the coming Olympiad than the previous Olympiad. And in particular, dynamic translators will have, now I think that will be modestly well contained. But it would be really important to me that once you guys get a functional port, and you too, Steve, once you guys get a functional port, we're really going to want to make sure that we get that working on all platforms. And I don't think that anything about that is going to be platform specific. I mean, it should all be pretty platform neutral. And the problem was when we wrote the code, the way history unfolded was not in our kind of wildest dream. So it was not designed to be portable code. And when we do the dynamic translators and the additional work that we do, we are much more mindful to that. But I think we would want to, and I think I would just ask the question more generally, what can we do to help you? Because we're obviously very excited by the effort, and I think that you've got the right ethos and trajectory. What can we as a community do to help accelerate your effort?
Well, definitely I would say to the extent possible, try what we have. Look it over. I mean, like any big piece of code, even though it's essentially a port, it's still a port. So I still look at my code every now and then and say, why on earth did I write that, and why hasn't this crashed yet? So the more eyes I look at things, obviously, the better as well. And I would say anything in terms of from all of us that basically we want to do in order to basically go from the current state of DTrace and make enhancements on there. Having open communication on that, I think is crucial.
Apologies for one more technical question. Just one thing I did want to raise. Are you doing anything about memory safety, or do you need to do anything about memory safety? One of the major issues we had, and I don't know if you guys have to deal with this or not, but knowing if an arbitrary VA mapped to I/O was before we did some other work in DTrace and other work in the kernel, you couldn't know that, and if a stray pointer load could induce problems with the device. In Linux, is it easier to know based on the VA before you actually issue the load whether that load is safe or not?
I can't say if it's easier. It's not easy. It definitely can be done, and it is one area that I have to say right now, because of the fact that it's not basically completely safe yet.
Right.
I don't have it in there at all, because again, it's one of those areas where it was probably safer to just leave it out, while we made it slightly more robust. which is also one of the areas where, for instance, where you basically compile a list of areas that are unsafe. You know, right now that list is empty, but that is in the works to get that done. But indeed, it's turning out to be still slightly more of a tricky issue, especially also with modules getting loaded. They do very funky things.
We had to change the way VAs were allocated the drivers for DMA ranges in order to be able to know.
Yeah,
So,
and
right.
it's a matter of, you know, it's there, it can be gotten to. There is just not really any sane way made available because nobody ever thought that somebody would need it.
Right.
And so we need to be able to tap into that, and like we have done in some other areas, that is obviously going
So it does
to
be
involve.
more difficult on Linux, because they don't have anything like DDA, DMA.
Yeah, I mean,
Yeah.
but
Can you just leverage system steps mechanism?
yeah, this whole presentation is so good. But it's your aspiration to make it safe with respect to memory.
Yeah, because it would be the same thing, you know. It could be a straight pointer somewhere, which, you know, has more than enough of them in various cases that indeed can cause basically this whole claim that it's stable and safe to basically come crashing down, and that's just kind of not acceptable.
Yeah, if we're ever sort of, if you can run the safety, the sections, I mean, personally seen the sections in DTest for safety,
Yeah.
And those came out of the various issues we had around, so if you can run all that, you're probably pretty safe. Those things are pretty nasty.
Yeah, I mean, we actually get through quite a lot of the test suite at this point, at least for, you know, except for things that depend on the provider that, you know, we currently don't have yet. But, you know, the goal is obviously to run through the whole thing without a problem. And it has uncovered some very interesting problems, and some of them were not on the side of DTrace.
I guess it's our last question, I promise. And
Sure.
apologize if it's overly contentious, but there is the Paul Fox port out there. Are you working with Paul? Or I mean, I know Paul made some very strange decisions. Have you kind of just gone a different direction, or?
Well, from my side, I've read about this port. Obviously, I've read, you know, things on his blog. I made a very deliberate choice early on after reading a little bit about, you know, how he was doing certain things, and that I'm not saying that he's going the wrong way or is going the way I don't like, but it was basically against essentially the concept of trying to stay as close as possible to the way the code base was structured, and, you know, how things were being done in DTrace. And so the conscious choice was made to basically not go a route of trying to, you know, use from what I read very strange constructs in order to be able to make things work, and to basically go straight for the fact that, look, in order to get DTrace really working on Linux and working it, you know, as something that is, you know, stable and very dependable, that, you know, there's no way around it. We need to make changes on the kernel side, and we need to integrate it basically as a kernel module, and, you know, break through some boundaries and make some things, like, for instance, make the system call table, you know, writable, you know, make those choices. And so I kinda, I don't know, for maybe just a reason of not wanting to get influenced in any possible way, I've actually not looked at his code. And that's definitely no disrespect to him, and I'm sure that his code probably is excellent. It's just my choice was, I shouldn't say my choice because it's an entire team, but I guess I've probably pushed the team maybe in a certain way, but was to basically say, well, no, we're going to go through a way where it is truly written as something that is going to be, you know, supported as, you know, part of the kernel, whatever way that needs to be done. And basically, so I decided that I'd rather not get influenced.
I think in particular the safety constraint, something that foreign platforms, I mean, I'd be interested to know if you had any debates internally, Steve, but I know for John in FreeBSD, John had a lot of ideas that he wanted to go explore, and we tried to tell him, it's like, he's going to violate the safety constraint. And he went off and explored a bunch of them, and I mean, it's a huge credit to John that he came back, you know, a year later and was like, those are all bad ideas. Those all violated safety constraint. But it took that kind of exploration to kind of understand that. And what I see in Paul, I mean, I think Paul's effort is great, and I admire it, and I'm glad that he did it. But I see some of the same kind of explorations, and in particular, it doesn't abide by the safety constraint. And for us, that is the epicenter of DTrace safety constraint. It sounds like that you share that ethos.
It definitely is, and from what I have actually, because like I said, I do follow his blog, I do follow postings that people make about it. It's from what I know about it, it definitely has also its place, and I think a very important place in the sense that, from what I understand, his approach can work with older kernels.
Yeah.
And that is significant in many ways, and I think that definitely has its place there. So I think that's quite an accomplishment.
How many of these safety constraint violation things could be pigeonholed off into the dangerous pragma category that would still be useful? I honestly don't know.
Unfortunately, the ones that can kind of are. There are, when you get into the innards of the implementation, as Kris knows from having been there are, in terms of what you're allowed to instrument, what you're allowed to do in instrumentation context, in the context of a probe, of an enabling, and what you're able to access in terms of the system. And there is no pound pragma option in DTrace, and nor will there be, that says I'm allowed to panic the system with data corruption. You can't allow that.
You don't say dangerous, you're saying destructive, which is actually very different, right? Destructive means this thing works in constrained ways that are predictable and well-defined. Dangerous is more like go ahead and try it, maybe it'll break, right? I mean, I think there's a very different connotation there, and I think that DTrace does allow for destructive actions, but again, those are well-contained and well-defined. It doesn't allow for dangerous options, which are unknown and potentially safe and unsafe.
Yeah, and honestly, the last time, which is probably about 2 months ago, when I decided that I was going to improve on something, I actually managed to get a Linux kernel in an extremely tight loop, which is actually, from my experience with Linux kernel, not the easiest thing to do, but it basically essentially was a probe that was basically circling back into itself and never getting out of it. And it's like,
yeah, we've been there. We've all been there.
I'm sure we all have.
And am I.
Forgive me if you keep going, and if this is too long a discussion, but you mentioned there are a couple places where you found room for improvement, and it'd be interesting to understand maybe just a vignette into one or two of those, or just like seeing the code at some point to see what those look like.
Well, one of them, and I wouldn't say it's necessarily directly room for improvement, it might more be a matter of differences between Solaris and Linux. But we found quite a lot of memory allocations that, if they would fail, would be rather disastrous. And
KM sleeps can't fail in Solaris.
And that is, that's what I figured was probably the difference, where the Linux behavior is slightly different.
Yeah.
And so we had a few cases where somebody, I can't do this memory allocation, and everything went horribly wrong. And there was one, and I can't think of it right now, and it probably is already way out of the code. And it's just one that sticks in my mind because it was such a glaring thing, is that based on the way the code was written, there was an assert that had a side effect. And basically, if you would actually turn off assertions, the side effect wouldn't happen.
You couldn't know about what that was.
And the code didn't work right.
That one's probably a bug.
So I'll dig up where that one was.
We'll probably get lucky.
So I'll send you an email. I have it written down somewhere. It's just one of those things that I thought, well, that's not good. And I sincerely hope that in production for Solaris that they compile with assertions on.
We don't, so
I figured so.
We're getting lucky somehow, or for some reason it's not.
It might be a very obscure place. So I'll definitely communicate that. But it's it's just the typical thing. It's such a humongous piece of code that you're bound to every now and then fall over something. And since I did this very progressive, according to execution lines, ports, function by function, it was really kind of, also as a person who basically has not been intimately involved with the code for a long time, kind of read that fresh look. Okay, so I need to now port this function. I'm gonna first read it. I was not taking the approach from, okay, plug it in, compile it, it compiles, now let's try to run it, let's see if it works. Really trying to understand, which honestly I have to say, probably taught me a whole lot about the internals of DTrace, and definitely has given me an appreciation for the design behind it, because it's truly a very beautiful design.
I have a quick question, but it's mostly point to you guys.
Good.
Is there a bare minimum list of action items that have been defined for people who want to port it to any operating system that would say, okay, if you port these, then you could call it DTrace.
Unfortunately, the actual answer to that, I think, just to, and I think Kris, you said it, is that 70% of the use of DTrace at this point is in userland, it's upstack, and so unfortunately, that set is everything. The PID provider is the steepest part, it's the most difficult part, and until you've done that, unfortunately, what you have is, it can be very useful. And we don't kind of bless DTrace ports kind of a ceremonial way. We should do that or John Rhodes. But the white smoke comes out when the DTrace port is announced. I think as a practical matter, let's take it as a practical matter of like Montclaw wanting to get the Rails probes into Rails, right? So what does someone need in order to make use of Kris Van Hees' work on Rails, on Linux, or on a different platform? They need the whole enchilada, unfortunately. And the only ones that have done that have been historically Apple and now FreeBSD getting there. And obviously want to help FreeBSD get there as much as we can and help Linux get there as much as we can, because we're not going to get to a point where we can get these things where we need them in this higher level software until it is non-negotiable and DTrace is everywhere. And by the way, there's even a company in Redmond, Washington, by the way, that's extraordinarily interested in DTrace on their platform. So I think that Amazon.
So from the point of view of the Lumos, right? I'm going to say something maybe a little bit heretical here, but I'd like to see the DTrace sort of like we've done with CFS. We've reached out to some of the other we call them foreign ports. What can we do to facilitate better collaboration between these ports, right? Are there simple things we can do into the code? Is there, is maybe just some maybe simple source restructuring that helps identify what the architecture specific parts are?
Yeah, we're totally open to that stuff. So whatever, and it's certainly where you find bugs, issues, things that we can do to help you out. Anything we can do to help you out, Steve, or anyone else out. You, Alex, anyone who is taking this code and dropping it somewhere else, we're totally open to it. So,
to the question, what is a DTrace port? Like, what's a DTrace port done? I think it's when the test suite runs. I don't know if Lumos even passes.
I would want to warn against that in the sense that one of the things that we definitely will also be communicating on is that test suite, at least as it exists in the Open Solaris version, some of the tests are written in a somewhat potentially error-prone way, where they might pass, but sometimes they don't.
It's a bug in the test suite. I don't think that it's like the test suite tests some implementation detail. The test suite has got. I'm sure you find lots of issues like that.
It's like rich flows, like don't compile with optimizations.
Yeah,
We assume things with floating point registers.
I would say definitely focus your energy on the Lumos version. Not the open source version is stopped, and it's the Lumos version. A bunch of us have made changes to the DTrace test suite in Lumos.
Yeah.
So we do view Lumos as the repository of record for that. So I would say draw from that, and where you've got bugs, and again, I'm sure there are tons. Let us know and we'll get those fixed.
Okay. Thanks very much.
Thank you so much.